Assalamualaikum and good day. I bid to all the panels. I am SYAHINDAH Husna Binti RAMLI. So today I would like to show you the video demonstration of my final year project titled Dual Polarized MEANDER Line Antenna at 3.5 GHz for Mobile Terminal 5G application. I am supervised under Dr. Imran bin Muhammad Ibrahim. So, the objective of my project is to design dual polarization antenna for mobile terminal 5G application. For sustainability, 5G is a promising technology that be expected for the upcoming 10 years, promises super fast data speed and the ability to underpin new technology. Meanwhile, for environmental friendly, it reduces number of try and error by the software. Only the best optimum design of the antenna will be chosen. So, the performance parameters that I study in my research are return loss, gain, directivity, and radiation pattern. So, here the demonstration of my project. I am using CST simulation software to design and simulate my antenna. So here is my first design, which I designed MEANDER line antenna in a vertical shape. And I am using FR4 with dielectric constant 4.3 for the substrate. Here is the back view of this antenna. Next, I will show you the far field of the radiation pattern in a 3D form. Here, we can see that the antenna radiates and develops the horizontal polarization with a gain 1.406 dB and the directivity is 2.297 dBi. For the polar form, we can see that the main loop magnitude is 2.3 dBi at 179 degrees. Next is the S parameters results. From this simulated result, we can see that the return loss is negative 21.975 that fallen at 3.1482. It means that this antenna has a low return loss and it goes for antenna. Here is my second design. I designed MEANDER line antenna in horizontal polarization. So here is the perspective view of my antenna. Front view and also back view. I am using substrate FR4 with dielectric constant 4.3. Next is the parameter of the return loss. It shows that the return loss is negative 23.919 dB that fallen at 3.2195 GHz. From this radiation pattern, we can see that the antenna radiates in a vertical polarization with a gain 1.156 dB and directivity is 2.130 dBi. So here is the polar form of this antenna. For the third design, I combine the vertical and horizontal of the MEANDER line antenna that fit together with the same substrate. I am using FR4 with dielectric constant 4.3 for the substrate. Here is the perspective view of the antenna and this is the back view. Next, I will show you the far field radiation pattern in 3D form. Here, we can see that the antenna develop a bit slanting polarization when they are combined together with gain 1.639 dB and directivity is 2.541 dBi. For the polar form, we can show that the main loop magnitude is 2.54 dBi with 178 degrees. For the S parameter, we can see that this antenna return loss is negative 16.774 dB that's fallen at 3.5522 GHz. Last but not least, I illustrate the design with the phone casing. I am using the design tree with the vertical and horizontal MEANDER line antenna to illustrate with the phone casing, and I'm using polypropylene for the material. Here is the perspective view. From the side view, we can see that the antenna and the phone casing is not touched with each other. The purpose of this illustration is to see that how the antenna will perform with the phone casing. Here is the far-field radiation pattern in 3D form. We can see that the antenna radiation develop a bit slanting polarization, same as the design tree, with a gain 1.229 dB and directivity is 2.449 dBi. For the polar form, the main loop magnitude is 2.44 dBi at 177 degree. For the S parameter, we can see that from the simulated result, the return loss is negative 22.845 dB that fallen at 3.5759 GHz. From the video simulation, I can conclude that to produce as dual polarization or in vertical and horizontal polarization, the antennas need to fit separately. Meanwhile, if the antenna combine together, the antenna will develop slanting polarization. For the simulation of illustrate antenna with phone casing is intended to show how the antenna can perform well in a practical and ideal condition. And from the video that I shown before, I can see that it is work. That's all from me. Thank you.